Back with this again. I received new capacitors, so I can attempt to reinstall the one that I ripped off this board with that solder splotch on it. The dimensions are slightly different, but shouldn't be too big of a discrepancy when it comes to fitting this inside that plastic housing. I'm going to pull a couple of these out and just test them for consistency. Just put these in a TC1 tester. 111 microfarad, 1.7% loss, 0.47 ohm ESR. 111, 1.7, 0.50 ohm. 118, 1.8%, 0.46 ohm. So these are rated 100 microfarad. That's close enough in the margin. I don't have a great deal of background to know how tight the tolerances are, whether 111 to 118 is what would be normal enough. For something like this, I'm not particularly worried. It still doesn't even work yet. So these are viable replacements for now. I won't install this quite yet because I do have a couple other points to get to as well. I appreciate the two of you that left comments here. Black Tie White Noise 2191 says maybe the voltage regulator is pumping too much voltage to it. Maybe the chip is fried if it got too much voltage. That is a really good point. Since at the very end of the last video, we did identify that this output pin is generating a lot of extra heat, that might well be this voltage regulator having failed. So we can test the voltage on that and see if that regulator is to blame. I'm hoping that hasn't caused the chip to fail. Again, we did see that intermittent time that it did connect properly and allow us to access and mount that USB drive. So I'm hoping that even if it is overvolting that chip, the chip is only failing to run properly and isn't fried and unrecoverable. But let's just take a reading. To do this, I'm going to set the tester to a 10 volt and probe that output pin against ground while I plug it in. At the same time, I'm going to plug that flash drive back in just in case we do get contact. We'll at least be able to see whether that's a factor while we're testing that voltage. So I'm going to set this up by putting our positive on the output leg. And if everything is well, we will see 3.3 volts. This is going to be about here on the tester. It's going to be somewhat difficult to get this plugged in and testing fast enough, but let's see what we get here. Plugged in. And that's actually about right, but our disc does mount and suddenly we're jumping a little bit higher. That might be 3.5 volts. I want to just hold here because if this happens the same way it did last time, this drive appears mounted, but at the point that that chip overheats, we won't continue to have access to it for too long. I want to see if that voltage ends up climbing or dropping or staying consistent. Okay, folder has disappeared and come back. Voltage is maybe getting a little bit less stable. I did see it wobble there for a second. Oh, voltage just dropped below 3 volts and it's climbing back up a little bit. My leads are pretty stable, so I don't think that was the problem, but it did remount the drive at the same time. So this voltage regulator may be part of the problem here. When I make minor adjustments to my hands, I don't see it fluctuate then, so I tend to think the needle fluctuating there really is the voltage output fluctuating. I'm pressing with a pretty significant force on both of them. That disconnect could have been my probe hitting the other pin, grounding it out for a second. I won't rule that out entirely. We're back up to a much more healthy looking 3.3. Okay, I'm going to remove my probes here. And let's try ejecting this disk properly. Oh, but suddenly we have a USB device not recognized. Problem ejecting. What has happened since I removed the pins? Now we have no disk. Oh, and we're high. We're about 3.5 Does it have something to do with putting pressure on those pins? That does seem a bit high. We're closer to 3.5 volts now. And we do see that unknown USB device, similar to last time. I'm going to pull my ground and replug the USB device. And closer to 3.3 again, and we're mounted, but we're trending high. 3.3. Is my probe using just enough of the excess voltage to cause this to work properly? If I pull this probe and just do nothing else, do we start having problems on the computer? Doesn't look like it. Oh, yeah, okay. Remounted. 3.5, maybe even closer to 3.6. So this voltage regulator does seem to be not particularly stable. I'm going to pull the probes again, see if we can eject the disc properly, see if it responds to that. No response to that request to eject the drive. Oh, we do have a safe to remove hardware. Now we have USB device not recognized. We're at 3.3 again. 3.0, 3.3. So it seems a little less than stable. I will also switch over to just measure the input voltage and see if that has any fluctuation. 5 volts, as expected. I imagine this will have caused quite a thermal soak as well. Let's just take a look at that. Yeah, the hotspot right now is 56.5 Celsius between either that chip and or the voltage regulator itself. So we'll unplug this at this point. So this VRM is definitely suspect. We can install the capacitors we just tested, just for good measure. Put that back to how it should have been in stock configuration. My second comment is more pertinent to soldering, which I'm about to do. The no clean flux pen. That's something that I had run out of and definitely saw the importance of in the last video, where making contact with those pins was enough to melt the solder on the contact surface, but the PCB was absorbing so much of the heat that the soldering iron wasn't sinking enough heat into the solder within that substrate. It was all soaking out into the PCB and causing the lower parts of that solder to remain solid and not let that capacitor pull out. So I did pick up another one of these no clean flux pens, similar to what's recommended here. And I will also do a better job tinning the end, cleaning that, making sure that that thermal contact is made from the end of the soldering iron tip, because that definitely was what bit me when I tried to remove this capacitor last time. Just quickly reminding myself the orientation. The negative side of this capacitor should face the exterior of the board, as I shown in that video last time. We're about back where we started here. The negative side on the outside. Perhaps I could have left a little bit more of the leads there, but I'm pretty happy with that. Apply a little bit more isopropyl. And there's our final product. Pretty happy with that. I'm just going to do the same test as before. We'll set this to 10 volts, plug in the USB drive. I don't think that capacitor is really related to that fluctuation in voltage, but we'll see if anything's apparently different here. Probe the output lead of the voltage regulator. Plug this in and try to get to the ground pretty quickly here so we get a pretty fast reading. And we're mounted. We're high. We're at 3.6 volts. You can see the thermal profile showing a lot of heat there. The hotspot still 56.8, 56.9. So that still strikes me as too hot for this to operate reliably. Hotter than I would expect, at least. I can just put a little resistance between the output rail and the ground just to drag the voltage down a little bit. Then we can simulate what a correct VRM would probably be doing there, giving it much more consistently 3.3 volts. And if we end up perfectly stable, then that's probably what will need to happen, is that VRM just needs to be replaced with one that's going to be providing a stable 3.3 volts, not one that fluctuates up to 3.5, 3.6. The first thing I found that was easily accessible is just a 9-volt battery connector. I'm obviously not going to plug a 9-volt battery into that, but this will allow me to get better contact on these two leads. So I am going to attach black to the ground and red to the output rail of that VRM. I'm going to grab my digital multimeter just to get a more accurate reading on the voltage there. We'll try something like this. We'll do the same test as last time. Plug our USB drive in. This time we'll have immediate power monitoring on both multimeters there. Oh, and I've done it negative. That's not what I meant to do. Try this again. Oh, and we're even higher, 3.7 on this scale. Although 3.1, 2.8, 2.7, 2.6. On the digital multimeter, seeing a bit more fluctuation than the analog is showing there. Okay, that's better. 3.32. Okay, so the analog is not perfectly calibrated. That definitely looks more like 3.5 and 3.6, but we're seeing 3.32 volts. I'm going to plug a heavier load into it. I assume our thermal is doing the same thing as before. Yeah, our hotspot is already 58 degrees. I'm going to plug the fan into it, since that's just a kind of a heavier USB load. See if that makes any meaningful difference to what the VRM is reading. Saw just a tiny little movement on the analog, but nothing at all really on the digital. Unplug that. That's really not moving at all. It's also functioning correctly today. We were seeing a much stronger thermal signature on the VRM before. They were almost even. I almost wonder if there was a cracked solder contact on the output rail, which would explain why there's a really localized thermal burn on the solder mask right where that contact is, but really not anywhere else. If I was making intermittent or weak contact, then there would certainly be problems. We're already up to 63 degrees on the thermal output of that chip. Still seems like a problem to me. But in the meantime, I'm going to eject this disk and replug it a few times just to see if this part is stable. While we're here, I can plug in a webcam as well. And there's a second camera. We are seeing very consistent 3.32 volts. So I wonder if it was just loose contact on that VRM. So I think what I'll do right now is remove my test apparatus from this and actually reflow those 3 pins pretty thoroughly so that all 3 of those VRM contacts are very solid to the pads underneath them, and test it for a while and see. That thermal profile seems hot to me, but it could be that this is normal for its design and that was never the problem. We can try to remove these guys now. And like I said, since we're right here, let's just dab a little bit of flux on here. Add some fresh solder to all 3 of these contacts on the VRM. Those look very healthy at this point. Let's clean this pretty well here. Still looks a little bit dirty in between those leads there. Just gotta do a little bit more. Looks like there's still flux on the inside of this. All right, that's pretty clean. Pretty confident that those solder joints are thoroughly attached to those pads. Let's go ahead and give this a final test before putting it back in its assembly, assuming it all still works and works reliably. I'm not going to plug in the thumb drive at the moment, but I will flip this over and monitor the thermals on the chip itself. See if I can consistently get it to show up correctly. And we're off to a bad start. USB device not recognized. So, okay, that's not entirely the fault here. We are seeing that thermal profile of the VRM is matching more closely with the thermal profile of the chip. Just set this back to voltage and see if we're still getting the same readings, since it is finally acting up right now. 3.32. Unplug it, plug it back in. Device not recognized. 3.32. Hard for me to get a reading for a second there. 3.32. 3.32. I assume our input is 4.84. Not too bad. Interesting, we're having more success with the USB drive plugged in. I'm going to just go ahead and do that for the sake of creating a similar case to the last test. Device not recognized. I'm going to press pretty thoroughly on that center of the output, since I was doing that for most of the last tests. 3.32. Out. Plug it in. 3.32. Something else has changed, even though that's the only thing we were directly interfacing with. And we'll just go ahead and probe along that same line, since, oh, now we're mounted. Same as before. 3.32. I want to probe here. 3.32. We're back to device not recognized. It hasn't really figured out that the disk isn't mounted. 3.32. 3.32. Wiggling this do anything to the stability. I think it's safe to say the VRM is ruled out as a possible source of problems here. The voltage is stable, the connections are now definitely secure, and our symptom comes and goes despite consistent output from the VRM. I wish I knew what else was at play between the functional runs and the defective runs. Just going to test all 4 ports, make sure there isn't a condition where a single port being used determines the outcome. Oh, see, now we get a camera. Interesting. Okay, so let's just keep that in mind. If this port's occupied, are we going to get success every time? I'm going to use the next port over and get my camera back. If I remove this, do I still get stable connections to that camera? Device not recognized. Interesting. Let's try the third port. Let's just try the problematic port again. Okay, let's try the first port again, and then we'll try the last. Let's try this last port. Yeah, the device not recognized. Okay, just try that one more time. So see if moving this changes anything. Back to working. Hold this up. Everything's smooth. Nope, dropped out. We have bad contacts in the cable this whole time. Yeah, just going to try to do a twisting test. Looks like we drop out. So this might actually be a simple case of a cable that's fatiguing and beginning to make intermittent contact at some point here. See if I can confirm that. So I do have a way of testing this. I have basically the opposite of that, which is a female USB connector, and it's just unterminated on this end. I've pulled it out of something. We'll plug those two together and use just a simple wire here connected to a lead. We'll use this digital multimeter again, since we can make it make noise on contact, like so. And we'll just test each of these pins that's making contact all the way through the cable, even when the cable is being moved around. So we can test the ground here first. We'll move that to the ground pin. Find the ground pin on this end, and give that a lot of twisting, etc. That seems solid. Move that to the first data line here. That a really thorough test. Move that to the next data line. Nope, we're not making contact. Up. Where is the break? Seems like it's right here. Is that just me not plugging it in well enough? Grab this steady. Back here. So it's definitely the problem if we're not able to make constant contact. Right here. Is it where it meets the connector? Is it just a bad crimp? Let me pull this out and see if there's just a crimp issue at the end of that cable. There we go. That's this cable. See strands of wire in here. Just going to put a little bit of solder on the inside of that crimp. Oh, and that just came right out. Well, that might be part of the problem there. If it was just barely hanging on. Let's try to slip this back together and see if we have a more stable connection. Oh, this is such a pain. Okay. It's just got two tiny strands hanging on there. Let's pull that out. Okay, not really proud of that, but it is reconnected. I'm going to test this same method as before. It does seem like that has created a strong link which resolves that intermittent connectivity. We'll just test that last positive lead for the sake of being thorough. Okay, Now to reinstall this in such a way that that bodge doesn't come into contact with anything. Looks like that is going to tend to face upwards. What I'll probably do is bend this back along itself. This is just a little piece of copper that I've used to bodge it here. Create a sharp bend in it. Just like so, and probably just loop it back on its way out. And that actually won't come into contact. It's sitting on top of the plastic. So we'll lose an inch of cable there, but I think that is just fine. Okay, appears to be back together. Okay, plug this in. Hopefully those contacts work. We do have our hub, which is connected properly. Plug this webcam back in here. And let's see if we can connect our webcam. We can. Give it a lot of flexibility tests, just like we did last time. And looks like all is well this time. You can plug in a couple other devices. Oh, we are mounted here. That's fine. And just for good measure, we can plug the fan in as well. And we're still connected. All 3 counts. I'd say that is good. Well, despite the long goose chase trying to figure out what was inevitably a simple thing, learned a little bit about soldering, replacing capacitors, diagnostic steps to take. That thermal profile on that really hot chip threw me off there for a bit, but it does seem like maybe that's just normal operating temperature for this USB hub. The dead giveaways that I initially examined, like potentially damaged pins or shorted bridge on either this end or these other ends, isn't too far off from what ultimately was the problem, which is just that the areas that bear the most stress are most likely to cause contact breaks, and there was just an intermittent connection on that white USB data line that was causing it to intermittently fail to detect basically anything. It was a floating or a very slightly connected data line. So now that that's been repaired and held in a place where it's not going to be fatigued, this hub should work for a while longer, and we can put this case to rest. So thank you very much for commenting. I appreciate the tips on soldering and using flux to get more heat soak, as well as looking into that VRM. That VRM did look like a likely candidate based on those thermal profiles, but at the end of the day, something much simpler. So despite that we had some interesting edge cases, like the bit of solder on the side of this capacitor and elsewhere on the board, it ended up being something simple at the end of the day. So never overlook what would have taken an otherwise working device and suddenly made it stop working. Those other things were probably there the entire time and never caused an issue, so there's not really a reason for them to cause an issue now. Thank you very much for commenting, providing those tips, and thank you for watching.